All right, today we are going to talk about a concept called optimization. Optimization is where you are optimizing something. What does optimizing mean? Make something better, to make it the best it can be. For example, any business would want to make their profits the best they can be, right?
Yes.
And their costs as low as they can be. Let me give an example of a business of a bakery, for example. So a bakery has to find out how many loaves of bread to bake in the morning, because that's how many they're going to sell for the day. If they bake too many, what happens? They have leftovers, it goes bad, and they've spent money on ingredients that they didn't recoup the costs of. If they don't bake enough, then they've lost customers, which is revenue that they could have had. So they've got to find the optimum number of loaves to bake so that they can maximize their profits while they minimize their cost. And that's just one example. So today we're going to be looking at real-world problems that ask you to maximize or minimize something. Have we been doing maxes and mins in class for a while?
Yeah.
Yes. Okay, so I want you to take a couple minutes and talk to your table about finding relative maxes and mins. Do you remember the steps to follow? So, 2 minutes, ready, go. Talk to each other. Do you remember what it is? What do you do? Okay. Remember that we put this in the flip book. It's right here. Okay, let's review what we got to do. 2 different things we look at in order to find our potential maxes and mins. What are they? Derivative equals 0 and if it fails. Okay? That group of numbers is called the critical points. Okay, after you have your critical points, you can go down 2 different paths. And today you get to choose. You can either go the first derivative path or the second derivative path. The first derivative path is where you go and you make a number line for f prime, and you put your critical points on it. Then you test points on either side, plugging those points into what? You plug into f prime, or do you plug into f?
F prime.
F prime. You plug into f prime because it's an f prime number line. You plug values on either side of the critical points into f prime to find whether it's positive or negative. Okay? The other option is to go to the second derivative test. The second derivative test is the one you want to choose when taking the second derivative. It's very easy. Okay? You take the second derivative, you check your concavity. If it's concave up, like a cup, is the critical point a max or min? The min. If it's concave down, like a frown, it would be a maximum. Okay? So you have your choice today as to which one to do. And as we do the 2 problems we're going to do, we'll talk about which choice is better. Okay? This worksheet right here, your notes, is set up with this A through G. Now this A through G is thinking questions. So as you do the homework, you may want to come and refer back to this because it's kind of the thought process you need to go through as you do your problems. So we're going to do this one together. It's got a little bit of a Christmas theme to it. So Chris wants to make pens for his 9 reindeer. He constructs the pens alongside the workshop as shown, with 9 equal-sized pens created with 10 portions perpendicular to the building. These are the little short pieces. And 1 long portion running parallel to the workshop as shown. If he has 4,500 feet of fencing available, what dimension should each pen have in order to maximize each reindeer's game playing area? Chris does not place fencing along the shared side with the workshop. He doesn't need to fence that side because the wall works as the fence. Does that make sense to you?
Yeah.
Okay. So, every optimization problem will either explicitly say maximize or minimize, or it will imply it through a word like farthest or closest or smallest or biggest. Okay? The first question it asks you in part A, what exactly in this question are you maximizing? What does it say? Look in the question, what am I maximizing? Reindeer's game playing area. So I am maximizing the area. I always like you to write that down because you're going to be creating several equations, and it helps to write those in words because the one you're taking the derivative of is the one that deals with area. Okay, so I need to move this up, I see. What are we maximizing? We're maximizing area. Write an equation to relate area to the variables in the picture. So I'm going to write A equals, do you see where my X and my Y are? What do I do to X and Y to find the area of the whole thing? Multiply them. So it's going to be X times Y. There's my equation. Okay. Now, unlike related rates, we are not going to do dxdt's and dydt's and things like that. We are going to force this equation to have only one letter on the left and one letter on the right. That's the next thing it says. Do you have two variables on one side in your equation? Yeah. In this case, the answer is yes. Usually you will. If so, find a secondary equation that relates those two variables to each other.
A over X equals Y.
Okay, that's taking the same equation and rearranging it. I want another different equation that relates X and Y only. No A's in it. Okay?
I was going to say, but X over 8 times Y.
No A's. The whole point is to get rid of a letter. What do you think?
If A equals X times Y, then can't X times Y equal X times Y?
Well, that is, well, yes, it could. Well, yes, it could, but that would kind of go in a circle and not get us anywhere. Okay. There is a number in this problem. What were you, was that what you were going to say? Okay, I see a 4,500.
Oh.
We haven't used that yet. Okay, the 4,500 talks about fencing. What kind of measurement is fencing as far as geometry? Perimeter. Okay. Now remember that 4,500 is all of these pieces, but not the workshop. So, how many X's and how many Y's make up the 4,500? Okay, hold on just a minute.
Whoa.
Two X's and one Y.
Okay, two X's and one Y, but there's X pieces in the middle too. We have to count those as well. Say it again, Angel.
10 X's and 1 Y.
10 X's and 1 Y make the 4,500 feet of fencing. Now, how did I know to use that? Well, there was a 4,500 in the problem I hadn't used yet, right? Bless you. So, okay. It says, find a secondary equation. I found it. So I've done part A and I've done part B. Part C says take the equation you found in part B, this one, and solve for one variable. It doesn't matter which one. Which equation would be, which letter would be easier to solve for? Y. So let's do it. Y equals 4,500 what? Minus 10x. Okay? So, plug this into the equation from part A to create an equation with only one letter on each side. So y equals this, agreed? So this is going to go where the y is. Yes, ma'am?
My lady said we get rid of the A.
No, we have to have the A there because we're maximizing area. We have to have the A. So the issue is we have X and Y on the same side of the problem. So we got to get rid of one of those. Okay? Remember in related rates, the test we went over just yesterday, where we had that question with R's and H's on the cone, and you had to take the derivative of the R and the derivative of the H, you had to use product rule, and a lot of people forgot. What I'm doing is keeping from having to do that. I'm getting rid of one of the letters so I don't have to do product rule. Okay? So now we have X times Y, which is 4,500 minus 10X. Are you following what I've done? Yes, ma'am.
Where the first X comes from? Oh wait, that's okay. Never mind.
You got it? Okay. So If I leave it like it is, I'm gonna have to do product rules. So let's go ahead and do some algebra and clean it up a little bit. So A equals 4,500x minus 10x squared. Now I have an equation with only a's on the left and x's on the right. That is now a function, so I don't have to worry about dAdt's, dxdt's, dydt's, any of that. I just take the derivative as it is. Okay? So, that takes care of C. I'm going to put a star by D. And the reason I am is that because it's not necessary to do it, it just could shorten your work if you do. So, letter D says, now let's take a look at the domain. What is the smallest your x can be? Now look at the picture. What is the theoretical smallest value x could be? Smaller than 1. Can you have a negative side of a fence?
0.
0 is the answer I'm looking for. 0 is the smallest x could be in theory. What is the largest x could be in theory?
Infinity.
Nope, I have a limited amount of fencing.
4,500.
Isn't it
4,500.
2 or like
450.
You both said it at the same time. It's 450. Angel, tell me how you got 450.
I divided by 10 because there's 10 x.
There's 10 x's. If I have 4,500 feet of fencing and I gave each x 450, I'd run out of fencing and would have nothing left for y. Does that make sense? So the answer that I'm looking for better fall between 0 and 450. That's why I think about the domain, okay? You don't have to write it down, but it's a good thing to think about. Now, it can't be 0, so I put a parentheses. It can't be 450, so I put a parentheses there. This is the domain, and when I get my x, anything that falls out of the domain, I throw it away. If you think about domain, if you get any answers that are not in your domain, you do not have to even look at them when it comes to finding maxes and mins. You can just throw them away. All right. Letter E is next. Here is where the calculus starts. Everything we've done up to this point has been no calculus. Letter E says take the derivative of your equation from part C, that's the one we just created, and set it equal to 0. That's how you find critical points, isn't it? So I know this is A, we're just going to call that A prime. Just like a y, y is y prime. Okay, please tell me you can take the derivative of the right-hand side of that equation. Yes, do it right now.
9,000x minus 20. What's 9,000 minus? Am I not reading that right? Then it's when.
What's the first term, guys?
4,500.
4,500 minus what? 20x, and we're supposed to set that equal to 0. Okay? Solve for x. Do the math. I didn't tell you to get a calculator out, but this would be a little bit easier with a calculator. The whole point is theoretically you could do this without a calculator. You only need a calculator for number crunching. You don't have to find the max by looking at a hill. What do you get for x? 225, okay? Does that answer fall in our interval?
Yes, it sure.
It sure does. Okay? So it's a potential max. That is a potential critical point. Or it is a critical point, but it's a potential max or min. Okay? Where else are we supposed to look besides where the derivative equals 0? If it fails. Does A prime fail? Don't call it F prime because there is no F in this problem.
No, it does not.
There's no x in the denominator.
If there is no X in the denominator, therefore the answer is no, it does not fail. No X in the denominator. Very good. Okay? Now, many people would assume that because that's my only answer, that's definitely the final answer. But in math, you can't just assume anything. You got to prove it. And the way we prove it is with the first or second derivative test. So we've done step E. It says use either a number line, which is the first derivative test, or the second derivative test to determine if this is a max or a min. Okay? Now, here we get to decision time. You may choose to do one test, and the person sitting next to you may choose to do a different test. That's totally fine. You should end up with the same results. Here's how you tell. Here's my derivative right here. How hard would it be to take the derivative again? Not hard at all. It's going to be a lot easier. And I want to go ahead and do second derivative test. I'm writing it down to remind myself to do it. Second derivative test would be take a double prime. And what is a double prime in this problem? It is negative 20. Now, according to the second derivative test, you're supposed to plug in your critical point. That's a problem. I have no place to plug it in. So, what do? Does that mean I'm stuck and have to go do the other one?
No, but just read the other.
The answer is no, it doesn't mean you're stuck. Okay, because my second derivative is always negative no matter what x is, right? That means that the graph of A is always what? Concave down. So write that down. A is concave down. Always. Okay? So if A is always concave down, what is the only critical point going to have to be, a max or a min? Max. It's going to have to be a max. So therefore, there is a relative max at x equals 225. And that is enough of an explanation / justification for this problem. Now, I think it's a good idea to do all the math and then go, wait a minute, was I looking for a max in the first place? Go back to the very top of your work. What was I trying to do? I was trying to maximize the area. I wrote that down. Did I get a max? Yes. If you wrote down max and you get a min, something's wrong. Now, unless you have 2 points and one's a min and one's a max, that's possible too. That's possible that it could happen. Okay. Now, I have done all the math. I finished F. Letter G is what a lot of people tend to forget to do. Summarize your answer according to what the problem is asking. What did the problem ask me for? I promise you, it's not just X. Okay. It did not ask you to maximize the reindeer game playing area. It said, what dimension should each pen be? You see this right here? That's the question. What dimension should each pen have? Now that's each individual square. How big is that square? What by what? It's 225 for sure, but the side length is not quite there. It's a portion of y. Do you agree with that? Yeah. Okay. So let's do a little picture. Let's pull a single pen out. I know that this is 225, right? Because it was x. What fraction of y is one side of this? Let me pull it back down so you can look.
9.
1/9.
Is it 1/10 or 1/9?
1/9.
There's 9 pens, and so that y side is divided into 9 pieces. Okay, you can go in and count them. And it is 9, so it's 1/9 of y. So now I need to find out what 1/9 of y is. Well, first of all, I don't even know what y is yet. Where's y? Where should I plug it in? Right there. In the y equals 4,500 minus 10x. So y equals 4,500 minus 10 times 225. So y equals, somebody with a calculator?
2,250.
That's 2250. So what's 4,500 minus 2250? 2,250?
Yeah.
Okay, that's the whole side of y. So I keep moving this up and down, I know. So what should I do with that answer to find out how long one of the little sides is for y? Divide by 9. So 1/9 of y, what is the answer when you divide it by 9? 250. Okay. Now, this picture is not enough. You have to write it in a sentence because they're not going to go looking for your work. The dimensions should be 225 feet by 250 feet. That's my answer. And if you want to add on to maximize the area. That's actually a better sentence. Okay? Do you have any questions? So let's yes, ma'am.
I sort of forgot where we got the 10 from, like the original 10.
Okay, we're gonna walk all the way back through the problem again. That's a good point. Okay, let's kind of walk back through everything because there's a lot of steps involved. First thing we did, we looked for what we were doing. Were we maximizing or minimizing? And what? What was it? In this case, we were maximizing. So we wrote it down and we wrote an equation for it. If we're maximizing area, we better write an area equation. If we're minimizing volume, we better write a volume equation. Okay? Then we looked for the double letter on this side, which we had, and we came up with a second equation to get rid of it. This usually happens. Once I got rid of the second variable, now I'm down to just one variable on each side. That's what I want. Now I'm ready to max or min it, to go through the calculus from here. Take the derivative, set it equal to 0, found my critical point, check to see that it failed. I chose second derivative test, found out it was a max. Then after that, I went back to my question and said, okay, what did the question actually ask me to do? So then I wrote a sentence making sure that I wrote down it was a max or min. Now, the question was just asked, where did that 10 come from again? How did we get 10x?
There's 10x.
There are 10 of these little x pieces along here. Okay, if you're going to make 9 pens, you got to have 10 sides. Yes, ma'am?
Why did we choose 1/9 for the y?
Because on this side, these are how many doors there are in the pens.
Oh.
So basically there's 9 doors. Oh, does that make sense? Yeah. Okay. Any other questions about this problem? Okay. These are the steps every single time, pretty much. So if you keep this handy, you can use it as you work the worksheet.